Now moving on from the k-means clustering, we will evaluate how hierarchical clustering works, and so for those who are unfamiliar with the k-means, I think you've missed out. Please refer my last video and you should be able to visit that. Now let's take a look at hierarchical clustering and how that works. So if you see, basic idea for hierarchical clustering is to calculate the Euclidean distance or different distance algorithm for the data points, and then build a dendrogram. So how it can be interpreted is ultimately the entire data set is terminated into a single cluster, but overall you would see a hierarchy. So how we can do that or achieve that is let's say if we have these 6 data points and we want to prepare a hierarchical cluster. The way we would do is we would use some of the algorithms like Euclidean distance, square Euclidean distance, Manhattan distance for your distance for your text clustering, and the others. So if we were to take a look for this one, the way you would build your cluster is, first you would based on the Euclidean distance for the data points from each other, you would kind of associate them. Let's say with here the A is closer to B, and if you take a look here and then go back, A is closer to B, and so is your C and D, and then after the C and D you again associate C and D with E, and then your C and D combines further. A and B combines with C, D, and E, and finally you have the entire cluster. This is your entire cluster. So you get the final cluster, and then what you do is, based on the number of required cluster, you take a knife and cut it across. So if you need 2 clusters, you would cut it here from based on the distance, square distance, your Euclidean distance, and if you need 4 clusters, you would cut it here. So what it terminates and gives you is this would form 1 cluster, this would be another cluster, and so would these 2. So you get 4 clusters out of these, while if I cut it here, I get this entire data in 1 cluster and this in 1 cluster. So based on that, and this can be interpreted only once you study the data. So that's important, to be able to study the data, find some pattern, and then decide what is the customer, in which cluster the customer belongs to. Is he a high paying customer or high purchasing customer? So you want a different set of recommendations for that kind of a customer. So yeah, this is again an unsupervised learning example, and how we would do that, let's see in R. So again, going by the same example that we had, we are going to use hierarchical clustering here. So we are going to use an average method for the wine, and then what we are trying to do is we are trying to cut this cluster in at a level 3, and then predict the value of the scored value against the calculated cluster. So we have, if you can see here, we have 3 different samples of wine: Evening Landing, Peter Michael, and Chalcedon Creek. The kind of results that we achieved with our k-means cluster, we were all over the place. We were all over the place. You can see here, and we were reasonably. This was the k-means clustering results for the 3 wines. We did reasonably well for Iris data set with k-means, but with wine we would and if you can see here with the hierarchical clustering, what you see is we have done much better. We have Chalcedon Creek 70 identified, Peter Michael 40, and Evening Landing 48. Oh, we just missed out on a couple of them, but we have done reasonably well. So this is again the predicted versus the known, since we know the sample of wine, but ideally this is an unsupervised learning model, so we wouldn't have the scored labels. But what I'm trying to say is, if we kind of studied the data and if we associate them, how well or how close would we be with this algorithm. So now again, going with the iris, let's try to cluster them up as well and see if we can do better, or even comparable. So yeah, you can see here we are very close. For Sentosa we almost clustered it perfectly, and so is for Virginica. It was reasonably well for Versicolor as well. So overall, yeah, so hierarchical clustering does a good job, and then there are different methods as well for us to do the clustering. You can as well use average, median, or centroid. So if you can see, you can use the centroid, average, and a median, and then again recompute your clustering results. So this is ideally very helpful when you're trying to build some recommendation engines, or when you're trying to associate. With this example, or with this algorithms, you can kind of do that, and you wouldn't need a labeled data to understand. You can create your own buckets, and then for an incoming data you can identify which bucket it ideally belongs to. So the first part, this is the first part of machine learning, I mean, where for unsupervised learning, where you try to identify the buckets, or when you're trying to create the labels from clustering, and then based on that label you want to predict for an incoming data, which is again for any supervised learning model that you used to do. So you would identify which is the closest bucket that this data belongs to, and hence you would act or accordingly. So yeah, great. So yeah, we'll take this ahead, and we will look at the principal component analysis of wherein we will see how we can select the right kind of attributes overall, and how we can do the feature selection and feature optimization with that technique. Thank you, friends.